Hello, my name is Evan Park, and I am a recent graduate of University of Maryland. Today, I'm going to share an aspect of my thesis research related to soil pore water halinity in coastal zone soils. While I was a student, I was tasked with reviewing relevant literature and formulating a proposal for the way that coastal zone soil survey scientists and technicians should measure and classify soil pore water halinity. Over the past year or so, I have reached some conclusions about what I believe the literature demonstrates to be a useful methodology and classification. And I've also encountered some challenges, especially when it comes to the differing approaches taken to coastal zone research by pedologists, ecologists, geologists, and others. So today I'm going to share my proposal and also discuss those sticking points. To begin with, halinity is the ocean-derived salt content of soils. It's important in estuarine and marine ecosystems because it impacts biogeochemical processes such as sulfate reduction, and it impacts the health of submerged aquatic vegetation and benthic fauna. Halinity has been of interest to coastal scientists for a long time, and one aspect of halinity-related research has been classification. The effort to categorize marine water and brackish water based on the salt content has been marked by two approaches. The first is to seek to create a common language, and this is best exemplified by the Venice System, which was developed in 1959 with the goal of being globally applicable. Its classes covered the range of halinity found in waters from Finland to South Africa, so its terms could be used virtually anywhere in the world. However, the thresholds between its classes were not related to any geographic, geologic, or ecologic criteria. The second approach is to classify halinity based on its ecological impact. Studies have defined classes based on the salt tolerance of plankton, or benthic fauna, or submerged aquatic vegetation. With this approach, the halinity classes communicate not just the salt content of a body of water, but also some information about the ecological community in and around that body of water. However, because the ecological impact of a given halinity value or range is not the same in different regions because of climate, geomorphology, or other reasons, this ecologically focused approach can lead to a proliferation of terms and methods that can be hard to relate to one another. After reviewing the literature, I came to the conclusion that the common language approach is more useful for halinity classification. Therefore, the classification that I propose is largely based on the Venice system, though it does incorporate some recent research on the threshold between freshwater and brackish subaqueous soils. This proposal intends to capitalize on the fact that most coastal zone scientists, whether they're soil scientists or others, are familiar with the Venice system and other systems that are based on it, including the US Fish and Wildlife Service system and the Coastal and Marine Ecological Classification Standard, also known as CMEX. This proposal accepts the trade-off that these classes are not tied to ecological impact, so they probably group together disparate ecological communities in some cases, or split them in other cases. Now, what really will give the ecologists heartburn is this here, calling halinity values up to 5 parts per thousand fresh. The justification for this threshold comes from research conducted in Rhode Island freshwater ponds, where Jonathan Bakken and Mark Stolt recorded conductivity values up to 0.6 decisiemens per meter, which calculates to approximately 5 parts per thousand. However, 5 parts per thousand is far above the salt tolerance of most freshwater species. Having discussed this with an aquatic toxicologist at University of Maryland, I believe that our ecologically minded colleagues would prefer to name this range of values oligohaline rather than fresh, and move the threshold between fresh and brackish water far lower, maybe to where the inland fresh class is at 0.5 parts per thousand. However, since this value, 5 parts per thousand, is being used as the threshold between fresh and brackish aquasols in the proposed wet soil order, I'm calling this class fresh in this current version of the classification proposal. I do want to point out, though, if our goal as pedologists and soil scientists is to foster interdisciplinary research in the coastal zone, we need to recognize that this threshold will potentially cause confusion and disagreement. If we want to move towards other scientific disciplines, we should consider naming this class oligohaline rather than fresh. But if we want to simply stand firm on pedagogically justification and compel other disciplines to move towards soil science and pedology, then this can be our fresh class. Honestly, if there's one thing that I've learned over the past year or so doing this work, it's that most scientists want to stick to their own conventions and justifications. So in terms of who moves towards who to help synthesize coastal zone research, I think that's a debate left to the luminaries. So for the time being, let's lay aside the classification proposal. It may proceed as is, or the threshold between fresh and brackish may change. But let us now focus on another issue of halinity, which is the way that it is measured. Halinity is usually determined through electrical conductivity measurements because salt molecules conduct electricity. Conductivity can be measured directly on water samples, or it can be determined for soil pore water through pore water extractions, soil pastes, or supernatants of diluted soil samples. There are many conversion factors in the literature for converting conductivity to halinity in parts per thousand, which is the commonly used unit, or grams per kilogram, which is the SI equivalent. One common method for determining conductivity of subaqueous soils is the 1:5 dilution by volume method, which involves taking 1 part soil, 5 parts distilled water, and measuring the conductivity of the supernatant. It's a simple method that can be done in the field, but it doesn't relate to the actual conductivity of the soil pore water, because of course that pore water has been diluted. I proposed and tested a new methodology that basically follows the 1:5 dilution method, but includes a couple extra steps so that data can be reported in terms of halinity, which reflects the actual condition of the soil pore water. We used moisture content measurements to determine the volume of water in the sample, and with that, we could calculate how much the pore water had been diluted. That dilution factor allowed us to convert from diluted conductivity to pore water conductivity, and then conversion factors in the literature were used to go from pore water conductivity to pore water halinity. This method is still simple and straightforward, but the ability to convert to halinity facilitates communicating soils data to other fields of coastal zone research that are more familiar with the parameter of halinity than they might be with diluted conductivity from the 1:5 dilution by volume method. We tested this method in South River, which was my master's research study site. It's a subestuary on the western shore of Chesapeake Bay. And generally, the pore water matched what we expected based on the halinity of the water column. Some of these high values were unexpected, but when we examined our method for potential sources of error, we concluded that these data are reliable. The examination did show us, though, that it's very important to prevent sulfide oxidation in subaqueous soil samples and to prevent sample water loss when making these halinity determinations using our method. So with that, what are the conclusions of this two-part proposal? In terms of the classification proposal, focusing on developing a common language is key. So using the Venice system as a guide to classify soil pore water halinity will be beneficial. Still, we need to recognize that this may require some give and take as we seek to synthesize pedagoggical research, justifications, and conventions with those of other bodies of research. And again, a notable instance is the threshold between fresh and brackish soils. The classes I proposed in this presentation may change, but I believe that the approach that I presented, the common language approach, should be retained. In terms of the methodology proposal, soil pore water halinity should be reported in terms of parts per thousand, since that's a widely known parameter that reflects the condition of the soil in situ. Finally, having tested the proposed method, we concluded that it is useful. It's simple and straightforward, and it produces quality data. To be most useful, again, care must be taken to prevent sulfide oxidation, and care must be taken to gather reliable water content data. So with that, I would like to thank you for your time. If you have questions or comments about this presentation or about my research, please contact me. I would be happy to discuss. Again, thank you.